If x and y are real numbers such that x square plus x minus 2y minus 1 the whole square equal to minus 4xy minus 4y square, then the value of x minus 2y is a properly tough question. And they just threw this and said, look, start off, let's see whether we can come swimming out of this one. And properly tough. I tried a bunch of cute things. I tried to bring something to one side. I thought there was an x square minus y square somewhere sitting there. An old-fashioned expansion worked. So x square plus 4y square plus 1 minus 4xy plus 4y minus 2x. A plus b plus c whole square is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. A square plus b square plus c square, 2ab, x into minus 2y into 2 minus 4xy, 2bc minus 2y into minus 1 is plus 2y into 2, x into minus 1 minus x into minus 2. This is equal to minus 4xy minus 4y square. Minus 4xy gets cancelled. So we have 2x square clubbing these two plus 8y square, this and this, this and this, plus 4y minus 2x plus 1 equal to 0. Nice. So nice big expression. I don't like dealing with x square and 8y square. Sorry, 2x square and 8y square. I'm going to break this down and say, look, x square minus x plus 4y square plus 2y plus 1 by 2 equal to 0. Right. Why? Because x square minus x square can be written as x minus something the whole square. 4y square can be written as 2y plus something the whole square. That helps, so we can go back and fall into completion of squares. Right. X square minus x plus 4y square plus 2y, x square minus x, 4y square plus 2y. It's a plus 1 that is still remaining. Right. What do we do? X square minus x plus what makes this a plus 1 or plus 1 by 2? Plus 1 by 2. Plus 1 by 2 is still remaining. X square minus x plus what can be a perfect square? X square minus x plus 1 by 4. X minus half the whole square plus 1 by 4. This can be of the form 2y plus something the whole square. 2y plus what the whole square? 2y plus a the whole square. Suppose we did 2y plus a the whole square. So it will be 4y square plus 4ay plus a square. 4ay should be 2y. 4a is 2, a is half. A square is 1 by 4. So I can put a 1 by 4 here and a 1 by 4 here. I have to subtract 1 by 4, 1 by 4. So minus 1 by 4, minus 1 by 4. So that's a beautiful expression, because now after doing all this, this simplifies to x minus half the whole square plus 2y plus half the whole square equal to 0. Plus half minus 1 by 4 minus 1 by 4 is 0. Adding all this takes us to 0. So this plus this plus this plus this is equal to 0. That is 0. Or this plus this should be 0. This is nothing but x minus half the whole square. That is nothing but 2y plus half the whole square adding up to 0. Or we get x equal to half. And we get y equal to minus 1 by 4. 2y equal to minus half. Y is minus 1 by 4. X minus 2y is half plus half, which is equal to 1. 0 equal to 1. X minus 2y is half plus half, which is equal to 1. Half minus 2 times minus 1 by 4, half plus half, which is equal to 1. Hopefully that is the answer. Super tough question. Square root of 5x plus 9 plus square root of 5x minus 9 is 3 times 2 plus root 2. Then square root of 10x plus 9 equal to 5. I struggled. Again, I struggled with this. Then I got cute and I said, look, can I do some jugad thing? I said, look, there's somebody setting the paper. It's possible that this gets mapped to this and this gets mapped to this. Hey, it is possible. So square root of 5x plus 9 is 6. Square root of 5x minus 9 equal to 3 root 2. 5x plus 9 should be 36. 5x plus 9 is 36, 5x is 27. 27 minus 9 is 18. Square root of 18 is 3 root 2. That is indeed right, it is true. So 5x is 27, we are through. Right? This is a cheating method. Right? So every now and then it really helps. But I'm not going to give you the solution based on this method. From an exam context, you need to be street smart and say, look, maybe whoever is setting the question has put this as this, put this as this, and said, look, let's jump around and play. It need not have been like this. The answer, this could have been 4 minus 2 root 2, and this could have been 2 plus 2 root 2, whatever, 2 plus root 2 to add everything up and bring it back together. Fine. So it need not have worked. In this case, it works. I just map this to this, map this to this, it worked, I'm through. And I can find the answer. Obviously, I can't do it like this. The textbook method is to say, hey, square this and then find that and simplify. Fine. So that's another beautiful method which Venkatesh friend pointed out to me. It's a beautiful method. This is a plus b. If I multiply that with a minus b, I'll get a square minus b square. Brilliant. So I'm treating this as a plus b. Root of 5x plus 9 plus root of 5x minus 9. Root of 5x plus 9 is a. Root of 5x minus 9 is b. I'll multiply by root of 5x plus 9 minus root of 5x minus 9. This will be equal to 5x plus 9 minus of 5x minus 9. Minus 5x plus 9. The beauty here is this side has x disappearing. This is 18. And this we know is 3 times 2 plus root 2 into this is 18. Which is brilliant because first of all we cancel the 3. This is 6. So this expression, square root of 5x plus 9 minus square root of 5x minus 9, which I'm going to call it as a and minus b from now on, that is nothing but 6 divided by 2 plus root 2. Multiply by 2 minus root 2, divide by 2 minus root 2. 2 plus root 2 into 2 minus root 2 is 4 minus 2, which is 2. This by this is 3. So a minus b is 3 times 2 minus root 2. A plus b is 3 times 2 plus root 2. Which is all very nice. Add these two, we get 2a equals 6 plus 6, 12, or a is 6, or square root of 5x plus 9 is equal to 6, or 5x plus 9 is 36, or 5x is 27. What do we need to find? Square root of 10x plus 9, 10x is 54, square root of 10x plus 9 is square root of 63, which is 3 root 7. Obviously, we came back at the same point. Square root of 5 plus 9 is 6. If you remember, this is where we started and said, look. So obviously, the cheating method or just plumping for it or just having your wits to just try out something sometimes works magically well. Not foolproof, not elegant, not perfect, not the way to learn this thing. But as you get some practice, understand that it's a competitive exam and you can poke around and get some answers, super powerful. It's like a proper superpower. You get a couple of questions by cheating, then. But cheating, I don't mean taking a bit of paper and copying the answer. Cheating is like not doing it rigorously from first principle, but finding some jugaad to do, go from answer choices or plugging in some values and trying it out. Right? So probably cheating is probably a very strong word. And you understand what I'm saying. Right? So poke around. This is very nice saying. Poke around and find out. Right? So like that. And I'm using the word poke around for politically correct reasons. Nice. So this is a good question, super tough. The other method for this is square this. You'll get an expression which is 2 root of 25 square minus 9. Bring everything to one side, square again, you'll get it. I did that method by substituting 5x equal to k. It's 5x, otherwise if you're dealing with 25x square, you can deal with k square, simpler. Numbers are simpler, juicier. Square once, bring everything to one side, square again, k square gets cancelled, solve, get k. Get to 5x, get to 10x, simplify. Right. Let n be the least positive integer such that 168 is a factor of 1134 per n. If m is the least positive integer such that 1134 per n is a factor of 168 per n, then m plus n equals n. At first cut, this looks like a tough question. It is not. Prime factorize is 168. I know is 24 into 7. Number of hours in a week, which is 2 into 3 cube into 7. 1134 is 2 into 567, which is a multiple of 9, 2 into 9 into 63, which is 2 into 9 into 9, 3 power 4 into 7. I've written this 2 into 3 cube into 7, which is incorrect. I'm sure you guys have spawned it already. It's 2 cube into 3 into 7. Nice. 1134 per n, 168 should be a factor of that. 168 should be contained within this. There are lots of 3s, lots of 7s. Even 1134 per 1 will contain 3s and 7s. That is sitting here. 2 cube, I need to have 3 2s in this number. This number is only 1, 2. So I have to cube this. So 1134 cube is absolutely necessary. Only then we will be able to get a 2 cube, which is important. We'll have lots of 3s, lots of 7s. It's not, this many 3s and 7s are not required, but we need 2 cube, or n is equal to 3. M is the least positive integer such that 1134 per n is a factor of 168 per m. Nice. This is a factor of 168 power m. Right. So 2 cube into 3 power 12 into 7 cube should sit inside 2 cube into 3 into 7 whole power m. You put m equal to 4, 2 power m equal to 1, 2 cube will be contained. 7, put m equal to 3, 7 cube will be contained, but we need 3 power 12. It's like a big number. M has to be at least 12. Minimum value of n minimum is 3, m minimum is 12. The minimum value m plus n is 15. Nice question. Once you prime factorization, just look at the numbers, look at the prime factorization, we are through. If x and y are positive real numbers such that log of x square plus 12 to the base x is 4 and log of x to the 3 times log of x to the base y is 1, then x plus y equals. Nice. First of all, that equation gives us x square plus 12 equals x power 4, or x power 4 minus x square plus 12 equal to 0. X power 4 equals x square plus 12. So x power 4 minus x square, minus 12 equal to 0. 12 can be broken as minus 3 and plus 4. So this will nicely, beautifully become x power 4 minus 4, x square minus 4 into x square plus 3 equal to 0. X square cannot be minus 3, so x square is 4, x is plus or minus 2. That's what we get from there. It cannot be minus 2 because the base is x, therefore x is 2. Nice, we just solved that quadratic equation in x square, simplify, we get x is 2. Then 3 log x to the base y is 1, so y power 1 equals x cube. Y is x cube, x is 2, y is 8. We want to find x plus y, 8 plus 2, 10, done. It seems like a very tough question, but it's not. Frame that expression in terms of exponents, solve for a quadratic in x square, we get x square is 4. X is plus or minus 2, it cannot be minus 2 because there is a base x sitting there, x is only 2. This one straight away gives us y equal to x cube, we are through. The number of integer solutions to the equation 2 power mod x into x square plus 1 equals 5x square. Nice question. First of all, we realize there is mod x here, there is x square here, there is x square here. If x equal to k works, x equal to minus k will work. If positive works, negative will work. If plus 2 works, minus 2 will work. If plus 11.3 works, minus 11.3 will work. Right? We can treat this as a quadratic in mod x or an equation in mod x. That way we can cancel everything merely. Understand that mod x, the whole square, is nothing but x square. So if we say mod x equal to y, 2 times y square plus 1 is 5y square. I can cancel a y. I can cancel a y keeping in mind that y could be 0. 0 works. And then we have, oopsie, 2y square plus 2 equals 5y. 2y square minus 5y plus 2 equal to 0. So 2y square minus 4y minus y plus 2 equal to 0. 2y into y minus 2 minus 1 into y minus 2 is 0. So y is half or 2. There's already a 0 that's possible. 0, half and 2, that works. This is y, which is mod x. So x could be plus or minus half, plus or minus 2 or 0. 5 different values are possible, but the question says number of integer solutions. Plus or minus half won't work. Minus 2 plus 2, 0. 3 different values. So 3 values of x work. Let alpha and beta be the 2 distinct roots of the equation 2x square minus 6x plus k equal to 0, such that alpha plus beta and alpha beta are the distinct roots of the equation x square plus px plus p equal to 0. Then the value of 8 times k minus p is equal to alpha plus beta and alpha beta are distinct roots. Alpha and beta are distinct roots of this equation. So alpha plus beta is minus b by a minus of minus 6 by 2, which is 3. Alpha beta is k by 2. Alpha beta and alpha beta are distinct roots of this equation. So 3 plus 3 comma k by 2 are distinct roots of this equation. So 3 plus k by 2 equal to minus p. 3 times k by 2 is equal to plus p. I'm going to substitute that here. 3 equals minus p minus 3k by 2. So minus p is minus 3k by 2 minus k by 2. Or 6 equals minus 4k. K equals minus 3 by 2. 3k by 2 is p, or p equals 3 into minus 3 by 2. 3 by 2 into minus 3 by 2, which is minus 9 by 4. 8 times k minus p. When you're doing 8 times minus 3 by 2 minus 9 by 4. 8 times 9 by 4 minus 6 by 4. 8 times 3 by 4. 8 times 3 by 4 of 8, which is 6. 8 into 3 by 4, which is 6. Is brute force this. Sum of the roots is minus b by a, product of the roots is c by a. Plug that in, keep solving it, we are through. The minor angle between the hour hand and the minute hand of a clock was observed at 8:48 am. The minimum duration in minutes after 8:48 am when the angle increases by 50%. Let's find 8:48 am. 3, 6, 9, 8, 7. So the hour hand should be somewhere here. 55. Minute hand should be somewhere here. And so let's first find out what the angle is. And so we take this as the reference point. 8:48. 48 is 4/5 of an hour. So 1/5 of an hour below 9 o'clock. This is 9 o'clock. 1 hour is 30 degrees for the hour hand. 1/5 of an hour is 6 degrees. So this angle is 6. Let's go to the minute hand. It's at 48. 60 minutes is 360 hours, 360 degrees. So 1 minute is 6 degrees. This is 3 minutes. This is 18 degrees. Nice. So it goes to the angle between the hour hand and minute hand is 24 degrees. I'm taking the reference point as the point where you're hitting the 9 point. Hour hand will be below that to the tune of 1/5 of an hour. Minute hand will be above that to the tune of 3 minutes. 3 minutes is 18 degrees, 1/5 of an hour is 6 degrees, 18 plus 6, 24 degrees, which seems about reasonable. We can imagine that being 24 degrees. When the angle increased by 50%, so the minute hand will keep going. Somewhere here, the hour hand would have gone even further away. Such at this angle, it's not 24 degrees, it is 24 into 1.5, which is equal to 36 degrees. We need to find that time. Fine, that's very weird to try to find that time. I'm going to flip this question. I'm saying the minute hand moves away by 12 degrees. It gains 12 more degrees vis-a-vis the hour hand. In 1 hour, in 60 minutes, minute hand gains 330 degrees. In how many minutes will it gain 12 degrees? That's it, through. In one full circle, the minute hand will gain 330 degrees. In how much time will it gain exactly 12 degrees? We are through. That's our time. This is a time beyond 8:48. The minimum duration in minutes after 8:40. That's exactly what we need to find. Our answer is this number, 12 into 60 by 330. Divide this by 2, this is 2, this is 11, 12 into 2 by 11, 24 by 11 minutes, little more than 2 minutes. We're through. The salaries of 3 friends, Sita, Gita and Meeta, are in the ratio of 5:6:7, 5x, 6x, 7x. In the first year, they got salary hikes of 20%, 25% and 20% respectively. 20% becomes 6x, 25% takes us to 7.5x, again 20% takes us to 8.4x. In the second year, Sita and Meeta get salary hikes of 40% and 25% respectively. Sita and Meeta. Sita gets 40%, this is year 1, year 2, 6x into 1.4, 8.4x. Meeta gets 25%, 25% is 1/4. 1/4 of 8.4 is 2.1, so this becomes 10.5x. And the salary of Gita becomes equal to the mean salary of the 3 friends. This is the mean of all 3 of them. If Gita is the mean of all 3 of them, Gita should be the mean of these 2. Gita's salary is 8.4 plus 10.5 by 2. Nice. The salary hike of Gita in the second year, divide this by this, we should be through. And then that will be 1 point something, the difference is the answer. 8.4 plus 10.9 is 18.9. 18.9 by 2 divided by 7.5. This is also x, this is also x. 18.9 by 15. That's the number we are looking for. Or it is 189 by 150. This is a multiple of 3. We can cancel off a 3. This is 63 by 50. 126 by 100. This is 1.26. Sita's salary is 1.26 times of what it was, or the increase is 26%. Yep, done. Lovely. A mixture P is formed by removing a certain amount of coffee from a coffee jar and replacing the same amount with cocoa powder. And so, coffee jar. I have, this is coffee plus cocoa. Nice. The same amount is again removed from mixture P and replaced with the same amount of cocoa powder to form a new mixture Q. Fine. New mixture Q. It will have even lesser coffee. This is also coffee plus cocoa. But this will have coffee here, cocoa here. Obviously, it's mixed, not in layers. Right? So we need to understand that. I'm just writing it down like this. When this is P, this is Q. The ratio of coffee and cocoa in the mixture Q is 16:9. This is 16, this is 9. Very nice question, because in this question we forget cocoa. Then say we start with coffee, the share of coffee reduces. Because I'm taking coffee out, replacing with cocoa. So if I'm removing half the coffee will remain. If I'm removing 1/7 the coffee, 6/7 will remain. If I am removing 1/8 of coffee, 7/8 will remain. From here, I am taking away both coffee and cocoa, but I am replacing with cocoa. So cocoa is being removed and cocoa is being added, but coffee is only removed. So I'm going to track coffee. Coffee is 16/25 of original. 16/25 is a very nice number. There is 4/5 whole square. I'm done. So here, coffee, if I had x units of coffee, at this step I have 4x/5. At this step I have 16x/25. I'm removing 1/5 of the mixture and replacing it with cocoa. That's all I'm doing. So x of coffee becomes 4x/5 of coffee, remaining x/5 is cocoa, becomes 16x/25 of coffee, remaining 9x/25 is cocoa. So coffee is x, 4x/5, 16x/25. Instead of this, I'm going to say coffee is 25, becomes 20, becomes 16. Initially, this is coffee, cocoa 0, cocoa is 5, cocoa is 9. 25 and 0 is what we start with, 20 and 5 is what is P, 16 and 9 is what is Q. Done. Then the ratio of cocoa in mixture P to the mixture Q. Cocoa in mixture P is 5, mixture Q is 9, 5 is to 9, that is there. 16/25 is 4/5 square. If you can just open up and say, like, look, I know that. This question becomes even simpler. Gita sells two objects A and B at the same price such that she makes a profit of 20% on object A and a loss of 10% on object B. And so, Gita selling price, 20% is 1.2 times the cost price. Loss of 10% is 0.9 times the cost price. So I'm going to say, look, I want my selling price to be a multiple of 1.2 and 0.9. Or I'm going to take my selling price as 108. Very important skill set. Super useful. 108 selling price, that is 1.2x, or x is 90. 108 selling price, this is 0.9x, 108 by 0.9, 120. She buys at 90, sells at 108, profit of 20%. She buys at 120, sells at 108, loss of 10%. Both are in. Nice, super useful. If you can take this number as 108, it becomes much simpler. If she increases the selling price such that the objects A and B are still sold at an equal price and a profit of 10% is made on object B. This is object A, this is B. She makes 10% profit on B, or B is sold at 132. Same price, A should also be sold at 132. Then the profit made on object A will be nearest, nothing, making 42, 42 on 90, 42 by 90 into 100. 42 into 10 by 9, 14 by 3 into 100, 140 by 3, 47. 141 by 3 is 47, 140 by 3 is 46.67%. There, done. Making this assumption as 108 really simplifies the question. Super simple question, especially in the context of everything else you've seen in this paper. Brishti went on an 8-hour trip in a car. Before the trip, the car had traveled a total of x kilometers till then, where x is the whole number and is palindromic. So, x remains unchanged when its digits are reversed. Nice, palindromic, we understand. At the end of the trip, the car had traveled 26862 kilometers till then. This number again being palindromic, 26862 is palindromic, 26862, 26862. If Brishti never drove at more than 110 kilometers per hour, then the greatest possible average speed at which she drove during the trip in kilometers per hour was. Nice. End of the trip. It took me a while to understand this question. End of the trip is 26862. 8 hours at some speed x. Beginning of the trip should have been some number. This is being told A, B, C, B, A. Palindromic. We want to find x. The greatest possible average speed at which she drove during the trip in kilometers per hour was x. Right? So this question is a number theory question, not really a speed time distance question. This number is a big thing. Maximum speed was 110 kilometers per hour, or maximum distance traveled is 880 kilometers. 110 into 8. Right? So if I subtract 880 from this, right, so 26862 minus 880. 16 minus 8 is 8, 9, 25982. This is the maximum number that could have been here. Any lower than that, the distance will be more than 880. And so my first two digits could be either 25 or 52. Sorry, 25 or 26. 26,862 kilometers have been traveled. When I started, I could have started with 25,000 something or 26,000 something. If I had started with 25,000 something, it should have been 25 something 52. Because it's palindromic. 25952 is less than this. 25 something 52 is not possible. Or this should have started with 26-62. So it would have been 26762, 268, 26662, 26562, 26462, 362. All of those numbers are palindromic. Now I want to find the largest possible average speed per kilometer. Average speed for her in kilometers per hour. This should be as high as possible. It should be as low as possible. 26 something 62 as low as possible. The mistake I made in this question, I put as 26162 and I got caught in the middle of nowhere. Luckily that answer choice was not there. 26062 to 26862 or a distance of 800 kilometers. She travels this in 8 hours, or her maximum possible average speed is 100 kilometers per hour. The amount of job that Amal, Sunil and Kamal can individually do in a day are in harmonic progression. The amount of job they can do individually in a day is in harmonic progression, or the number of days taken should be in arithmetic progression. Kamal takes twice as much time as Amal to do the same amount of job. Or if Amal takes X days, Kamal takes 2x days, and Sunil should be taking in between 3x by 2. The number of days should be in AP because the time amount of work done is in HP, which is all very nice, but I don't want to deal with x, 3x by 2, 2x. I'm going to say, I'm going to erase this. It's very interesting. Let's call this as 2y, 3y, 4y, number of days. Amount of work done will be 1 by 2y, 1 by 3y, 1 by 4y. They are in HP. 2y is into 2 is 4y. That works. If Amal and Sunil work for 4 days and 9 days respectively, Kamal needs to work for 16 days to finish it. Nice. 4 days, 9 days, 16 days. Amount of work done is 4 by 2y plus 9 by 3y plus 16 by 4y. They complete the task. 4 by 2y is 2y, 9 by 3y is 3y, 2y plus 3y plus 4y, so 9y equal to 1. Sorry, 9 by y is equal to 1. 2 by y, 3 by y, 4 by y, or y is equal to 9. Or Amal takes 18 days, Sunil takes 27 days, Kamal takes 36 days. Then the number of days Sunil will take to finish the job working alone is 3y, 27 days. Very important to understand, if an amount of work done in a given day, the three numbers are in harmonic progression, the number of days taken will be in arithmetic progression. And then we know this is twice of this. So instead of taking x, 3x by 2, 2x, we can take 2y, 3y, 4y. That much simpler. I'm not dealing with a 1.5. After that, we just mechanically write down the answer. Arvind travels from town A to town B, Surbi from town B to town A, both starting at the same time along the same route. After meeting each other, Arvind takes 6 hours to reach town B, while Surbi takes 24 hours to reach town A. Nice. A to B. Arvind goes from A to B, and Surbi goes from B to A. Arvind takes 6 hours to reach town B, while Surbi takes 24 hours to. Nice. They meet somewhere, and 6 hours Arvind reaches here. They meet somewhere, and then in 24 hours Surbi reaches here. They meet at this point. I put the point to be closer to B because Arvind reaches in 6 hours, Surbi takes 24 hours. Right? The first thing to note is both of them take the same time to travel here, some T hours. Nice. Let's say Arvind's speed is A and Surbhi's speed is S. So beautiful question, standard template. I'm going to do it by the juiciest method possible. Fine. To travel this distance, the times taken are T and 24. To travel this distance, times taken are 6 and T. Right? A into T is S into 24. A into 6 is S into T. Ratio of their speeds, if I'm taking about A by S, should be the reciprocal of the ratio of their times taken. It should be equal to 24 by T. It should be equal to T by 6. Or if Arvind and Surbhi take T hours and 24 hours for one journey, one distance, and 6 hours and T hours for another distance, the ratio of the times they take should be the same. If Arvind takes 5 hours for one journey and 4 hours for another journey, if Arvind takes 10 hours for another trip, Surbhi takes 8 hours for the second trip. The ratio of their time should be the same, inverse of the ratio of their speeds. Or forget about this. 24 by T equal to T by 6. 24 into 6 is 144 equals T square. T is 12. It cannot be minus 12, it's just 12. If Arvind traveled at a speed of 54 kilometers per hour, the distance in kilometers between town A and town B, this is 12. Arvind travels at 54 kilometers per hour, travels for 18 hours. So the distance is 54 into 18. 18 4 are 72, 972 kilometers. Lovely question, but standard template. T square equal to 24 into 6. T is square root of 24 into 6. 12. Done. Anil invests 22,000 for 6 years in a certain scheme with 4% interest per annum, compounded half early. Sunil invests in the same scheme for 5 years, then reinvests the entire amount received at the end of 5 years for 1 year at 10% interest. The amounts received by both at the end of 6 years are same. Then the initial investment made by Sunil in rupees is a nice question. So 22,000 into 1.02 to the power 12. 6 years compounded half yearly, 12 compoundings, 4% per annum, so 2%. If Sunil has invested rupees X, 1.02 into power 10. Same scheme for 10 years, so 5 years, so 10 compoundings at 2%, and then takes the amount and gets 10% extra into 1.1. These two are equal. 1.02 per 10, 1.02 per 12, we'll have a 1.02 square remaining here. So 1.1 there, but at 22,000 here, lovely. So it should be 20,000 into 1.02 square. I know 1.02 square, which is 1.0404 into 20k. It should be 20808, 20,808. He should have put in 20,808 to get the same amount as Anil would have got at the end of the 6-year period. Again, routine question, you should be knocking this off, especially in the context of this paper. Let C be the circle x square plus y square plus 4x minus 6y minus 3 equal to 0, and L be the locus of the point of intersection of a pair of tangents to C with the angle between the two tangents equal to 60 degrees. Locus of the point of intersection. Seems like a very funny thing, but it's actually a very nice, interesting question. Forget this. Draw a circle and say tangents from some point are 60 degrees away. Fine. So now just imagine this. If I can find two tangents from this point that are 60 degrees away, you can say this is O, this is the radius R, join this is the radius R, this is 90 degrees, 90 degrees. These two are congruent, tangent. So this will be 30, this will be 30. If radius is R, this distance is R root 3, tan 30 is 1 by root 3, sin 30 is half, this distance is 2R, this is R, this is R root 3. First of all, instinctively, you should recognize that if I have a 60 degree tangent angle, it's outside the circle, and anywhere I move around the arc, parallel to the arc, It should continue to be 60. And move like this. If you can sense that any point on a bigger circle, this will be satisfied, life is super easy. This is R, this is 2R. So whatever the radius of this circle is, radius of the circle where the tangent makes 30 degrees, the two tangents make 60 degrees, will be twice of this with the same center. So this circle, concentric circle, is twice the radius. That is the locus. That's what we are looking for. Then the point at which L, that is this bigger circle, touches the line L equal to 6, x equal to 6 is, so let's for which we need to dig deeper. X square plus 4x plus 4 plus y square minus 6y plus 9 equals 3 plus 4 plus 9. I'm taking the 3 that side, adding 4 and 9 on both sides, or this is x plus 2 the whole square plus y minus 3 the whole square equal to 16, or radius is 4, center is minus 2 comma 3. Then the point at which L touches the line x equal to 6 is, this is our circle. Circle 2, which is the locus, is nothing but x plus 2 the whole square plus y minus 3 the whole square is not 16, not 4 square, but 8 square. Bigger circle, twice the radius, same center. Where it touches the line x equal to 6, what do we need to do? Put x equal to 6. 8 square plus y minus 3 whole square is 8 square, or y equal to 3. Or quite clearly, it touches at only one point, 8 comma 3, or the line x equal to 6 is a tangent to this circle. X plus 2 plus y minus 3 whole square equal to 8 square. It touches at the point 6 comma, x equal to 6 comma 3. 6 comma 3 satisfies this equation. Yes. Lovely. A quadrilateral ABCD is inscribed in a circle such that AB is to CD is 2 is to 1, BC is to AD is 5 is to 4. Nice. We'll draw a quadrilateral. AB is to CD. AB, CD should be shorter. BC is longer, so you put it like this. So 2x and x. AB is to CD is 2 is to 1. BC is to AD is 5 is to 4. This doesn't look like that. 5y is to 4y. If AC and BD intersect at point E, then AE is to CE. They meet at point E. We want to find AE is to CE. Nice, lovely. We know this is a cyclic quadrilateral. It's inscribed in a circle. So we know a bunch of properties from that. What do we know? We know that angle ABD is equal to angle ACD. This is alpha. This is alpha. We know from this side, this is beta. This is beta. This is theta. This is theta. This is beautiful because this is vertically opposite angles. Angle made in one part of the circle by an arc. Again the same. This is beautiful because these two triangles are now similar. And in what orientation we can say triangle AOB is similar to triangle. A has the angle beta, DOC. What do we know? We know AB by CD. I'm going to get that. AB by CD equals AB by CD equals OB by OC equals AO by DO. I mark it as O, it is E. So for me, O is E. Okay. Or let me simplify this, let me not do this. Let me say very clearly, this is, fix that. AEB is similar to DEC. AB by CD is EB by EC equal to AE by D. AB by CD is 2 is to 1, which is EB by EC, EB by EC. This is 2K by K, which is AE EB by EC, 2K is to K. And AE by DE, 2M is to M, which is all nice, brilliant, useful. But we want to find AE is to CE, AE is to C. We need to find 2M is to K. We need to still link M and K, which is a pain. Right? But not such much of a pain, because if these two are similar, these two fellows should also be similar. And so these two angles are equal. And we know that this angle is equal to this angle. If this angle were gamma, this should be gamma. So we can again say triangle AED is similar to triangle BEC. These two angles are equal, these two are equal. These two will automatically be equal, this and this. Okay. Therefore, we know AE by BE is AD by BC, AE by BE equals ED by EC equals AD by BC. AD by BC is 4 by 5. ED by EC is therefore 4 by 5. M by K is equal to 2M by 2K equal to 4 by 5. What do we need to find? We need to find AE by CE. AE by CE, M by K is 4 is to 5. We want to find 2M by K, which is 8 is to 5. This answer. Beautiful question, challenging question. So we have a cyclic quadrilateral with the diagonals intersecting somewhere in between. These two are similar, these two are similar. We use that and we manipulate in n different ways. We can find all kinds of equations, simplify everything. Answer is 8 is to 5. And so we know this ratio, we know this ratio, this ratio. We know this ratio. M by K or 2M by 2K, both are 4 by 5. We know that M by K is 4 by 5, 2M by K is 8 by 5. In a right angle triangle ABC, the altitude AB is 5 cm and the base BC is 12. So it's 5, 12, 13. Nice. ABC 5 centimeters, 12 centimeters, AC should be 13. P and Q are 2 points on BC such that the areas of triangle ABP, ABQ and ABC are in arithmetic progression. ABP, ABQ and ABC are in arithmetic progression. PQ. This area, bigger area, biggest area are in AP. The area of triangle ABC is 1.5 times the area of triangle ABP. Nice. ABC area, triangle ABC area is half into 5 into 12. Sorry, which is 5 into 6, 30. So area of triangle ABP equals 30 into 2 by 3, which is 20. Half into 5 into BP is 20, or BP is 8 centimeters. The whole thing is 12. What do we need to find? We need to find length of PQ. And so these three areas are in AP. Area of triangle ABP, ABQ and ABC are in AP. The heights are the same, AB. The three numbers should be in AP. BP, BQ and BC should be in AP. The three bases should be in AP. BP, BQ, BC should be in AP. This is 8, this is 12, it should be 10. The length of PQ, this is 8, the whole thing is 10, PQ is 2. The number of all natural numbers up to 1000 with non-repeating digits. All natural numbers up to 1000 with non-repeating digits. And so up to 1000. So we have a number like 236, we'll count it. We have a number like 668, we won't count it. And so 236, we'll count it. 668, we won't count it. So to do this, we have 3-digit numbers and 2-digit numbers and single-digit numbers. I'm going to say all numbers from 0 to 999. Natural numbers 1 to 1000. I'm going to think of it as 0 to 999. 0 and 1000 we won't count anyway. 0 to 999 we are counting. 0 will ignore. 999 doesn't count. Instead of 1 to 1000 we're doing 0 to 999. Nice. So A, B, C non-repeating digits. Nice. So A could take values from 0 to 9. B will be 0 to 9 except A. C will be 0 to 9 except A comma B. So this will be 10 possibilities, 9 possibilities, 8 possibilities. 10 into 9 into 8, 720. 720 different numbers are possible. Remember, this could be 0. If I have a number like 078, that will get counted. If I have a number like 016, that will get counted. It will get counted here. I'm not thinking in terms of 3-digit, 2-digit and single digit. I'm counting in terms of all numbers from 0 to 999. 1000 anyway won't get counted. So it doesn't matter. So now I'm saying, hey, all of these get counted, but there's no 720 in the choice. I'm in trouble. Why is 720 not in the choices? I look at this and go, why has 720 not been included here? 10 into 9 into 8. Right? So now, if A were 0 and B were 1, C were 6, that will get counted. 0 to 9 except A, 0 to 9 except A and B. All 3 digits should be distinct, non-repeating digits. Nothing should repeat. So 0 to 9, 0 to 9 except A, 0 to 9 except B, A and B. And so 3 digits being distinct, we are counting all of them, all possibilities. Now, is there something that we are missing out here that we should actually be counting? And so if you think about single digit numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, they get missed out. Why do they get missed out? Because there will be 004, 005, 006, all of that. And I should be counting that. And I end up not counting that. So I should count those. So these two both being 0, I should count them. So now I realize, okay, this is all interesting, but because I've introduced the 0, it's complicated. This is the marks in the bag. So I'm going to get this down. I'm going to say ABC, numbers the form AB, numbers the form A. 9 numbers of this type, put it in the bag. This is 0 to 9, 1 to 9 except A, 1 to 9 except A comma B. So this is, 1 to 9, 0 to 9 except A, 0 to 9 except A comma B. 1 to 9 has 9 possibilities, 8 possibilities, 9 to 9 into 8, 81 into 8, 648. This is 1 to 9, 0 to 9 except A, 9 into 9, 81 possibilities, plus 9, we're looking at 648 plus 81 plus 9, 10, 18, 8, 1, 5 plus 8, 13, 3, 1, 738, done. Initially, I tried to do it by this method. And then I got confused. I got worried because there are some numbers where there are 001, 002, I should count them. So I'm worried about this. So I'm like, I might end up missing something. I don't want to do this. I know that 3-digit, 2-digit, 1-digit number works. Let me fall back into that method. So 3-digit ABC, 1 to 9, 0 to 9 except A, 0 to 9 except A comma B. 1 to 9, 0 to 9 except A. 9 numbers here. 648 plus 81 plus 9. I'm through. Done. Very happy. Wonderful question, nice and challenging. Let's attack this. X cube plus 2r plus 1 x square plus 4r minus 1 into x plus 2 equal to 0 has minus 2 as one of the roots. The other two roots are real, then the minimum value. We've got x equal to minus 2 as one of the roots. So I thought, hey, nice. We just plug equal to x equal to minus 2, see where it goes. Maybe we'll be able to solve for r, and that r is the answer. You get r equal to 4, that's the answer. Minimum non-negative integer value. R has only one value, we are through. Substitute x equal to minus 2 here, we have minus 8. Plus 2r plus 1 into 4 plus 4r minus 1 into minus 2 plus 2 equal to 0. Solve for r, we are through. Right? Oops. Minus 8 plus 8r plus 4 minus 8r plus 2 equal to 0. 4 plus 2 is 8. So minus 8 goes off. 8r minus 8r is 0. So this equation works But quite lovely, we get that this is independent of r. We cannot solve for r. What it's telling us is that that giant expression has x plus 2 as a factor, or x equal to minus 2 works no matter what value of r we take. So we hit a dead end here, not solving for r and getting something. But you're on to something. We go to the next step and say, hey, we have x cube plus 2r plus 1 times x square plus 4r minus 1 times x plus 2. For this expression, x plus 2 is a factor. Substitute p of minus 2, that is 0, or minus 2 is a root, x plus 2 is a factor. So let's factorize this. When x square goes here, this is x cube plus 2x square. We subtract this, 2r x square will come, plus x square minus 2x square. So 2r minus 1 times x square plus 4r minus 1 times x. We bring down the next term. We have an x here, we have to have 2r minus 1 x square, so plus 2r minus 1 times x. So what do we get here? 2r minus 1 times x square plus 2 into 2r minus 1, which is 4r minus 2 times x. We subtract this. This goes away completely, just like how this went off. 4r minus 1 minus of 4r minus 2. 4r goes off, minus 1 plus 2. This is x plus 2. So plus 1. This gives us an x plus 2. Quite lovely. This expression can be written as x plus 2 into this expression. Now this expression, x square plus 2r minus 1 times x plus 1, has two real roots. They could be just two, the other two roots are real. Fine, so super lovely. So I have an expression which is x square plus 2r minus 1 times x plus 1 equal to 0. This has real roots. Two roots are real. That means b square minus 4ac should be greater than or equal to 0. We solve that, we get an inequality in r. That we can solve, we are through. So b square is 2r minus 1 the whole square, 4r square minus 4r plus 1 minus 4 into 1 is greater than or equal to 0. Or 4r square minus 4r minus 3 is greater than or equal to 0. We should be able to factorize this. 4 into minus 3 is 12, minus 6r plus 2r will work. So 4r square plus 2r minus 6r minus 3 is greater than or equal to 0. 2r to 2r plus 1 minus 3 into 2r plus 1 is greater than or equal to 0. 2r minus 3 into 2r plus 1 is greater than or equal to 0. So x is either r is greater than or equal to 3 by 2 or r is less than or equal to minus r outside of the two roots. We want the minimum possible non-negative integer value. So this side is out, negative. It should be greater than or equal to 3 by 2, greater than or equal to 1.5. So minimum integer value is 2. Super tough question, super time consuming. We take this big polynomial divided by x plus 2, get a quadratic expression. That quadratic expression has real roots, discriminant should be greater than or equal to 0. Plug in the discriminant value, get a quadratic inequality in R, and then say R should be less than or equal to minus half or greater than or equal to 3 by 2. Then we look for the minimum possible non-negative integer volume. So less than or equal to minus half, we forget about it. Greater than or equal to 1.5. 2 is the smallest possible positive integer value, non-negative integer value. Answer 2. In examination, the average marks of 4 girls and 6 boys is 24. Girls and boys, the average is 24. We're mixing them in the ratio 2:3. 4 girls and 3 boys. Each of the girls has the same marks while each of the boys has the same marks. And I've already incorporated this because we're mixing them. I know that fact, I've read this question. And so The marks of any girl is at most double the marks of any boy, but not less than the marks of any boy. So girl's mark less than or equal to twice of boy's mark, greater than or equal to boy's mark. Girl's mark is more than boy's mark, or at least equal to boy's mark, less than or equal to 2 times boy's mark. Right? The average is 24. Then the number of possible distinct integer values of the total marks of 2 girls and 6 boys is. Right? So 2 girls and 6 boys, how many different integer values it can take? Right? So 4 girls and 6 boys add up to 240. 2 girls and 6 boys should add up to an integer, or 2 girls should add up to an integer. 2 girls plus 6 boys is an integer, is 240. 2 girls and 6 boys should be an integer, or 2 girls should be an integer. And that's what we're trying to solve. Or the girl's mark, we can go step by step and try to figure this out. 2 girls and 6 boys should add up to an integer. How many different possible integer values exist? That's what we are trying to find. So first of all, I'm going to put the extreme condition. Let's put boys equal to girls. And so this is 24, should be 24, it should be 24, 24, 24, 24, average is 24, boys mark equal to girls mark. Right? Girls could have got 24 marks, boys could have got 24 marks, nice and fun, done. Other scenario, girls could have got twice of what boys have got. 4 girls and 6 boys, mixing in the ratio 2:3, 2 into 2x plus 3 into x. By 2 plus 3, 5 equals 120, so equals 24. 4x, 7x equals 120, x is 120 by 7. Or boys mark should be 120 by 7, girls mark should be 240 by 7. The maximum marks girls could have got is 240 by 7. So G minimum is 24, G maximum is 240 by 7, whatever that is. 7 into 30 is 210, 210 plus 30 by 7, 34 2 by 7, a large number. So from 24 to 34 2 by 7, all of those values are possible for girls. Right? 24, 24.1, 24.2, etc., etc., etc. Right? So very interesting question. So G can go from 24 to 240 by 7. That many different values G can take. Now simplify this. We want 2G plus 6 boys to be an integer. We know 4 girls plus 6 boys is equal to 240. 4 girls plus 6 boys divided by 10 is 24. The average marks is that. Right? Or if I subtract one from the other, 2 times girls mark should be an integer. From this 240, I subtract 2 times girls mark, I should get this. From 240, I subtract 2G, I should get an integer, or 2G should be an integer. Right? The minimum value of G is 24. 2 times G should be an integer, or G should be either an integer or integer and a half. 24, 24 and a half, 25, 25 and a half, 26, 26 and a half, some combo like that. So what are the values G can take? G can take values 24, 24.5, 25, 25.5, 26, 26.5. Up to what? Can it go till 100? No, it cannot go till 100 because the maximum value G can take is 340 by 7, 240 by 7, which is 34, 2 by 7. 30 into 7 is 210, another 30 remaining. 7 into 4 is 28, so 34, 2 by 7. So G can go only up to 34, 2 by 7. But if we keep on doing this, it can go up to 34. From this onwards, it doesn't work. How many values can G take? 24, 24 and a half, 25, 25 and a half, 26, 26 and a half, all the way till 33, 33 and a half, and then 34. It cannot take 34 and a half because our condition will get violated. Or all of these values G can take. There are 24 to 33 10 numbers, 10 natural numbers, and then plus half, 20, plus this one, 21. So G can take 21 different values. Absolutely delightful question, nice and juicy, very properly challenging. For some positive and distinct real numbers, that is x not equal to y not equal to z, 1 by root y plus root z is the arithmetic mean of root x plus root z and root x plus root y. Then the relationship which will always hold true is y, x and z are in arithmetic progression, root x, root y, root z are in arithmetic progression, x, y and z are in arithmetic progression, root x, root z, root y are in arithmetic progression. And so all are arithmetic progression, which is very nice. Very happy with that. Sometimes they give AP, GP, HP and bore the hell out of us. Root y plus root z is a meaning of root x plus root z and root x plus root y. Z and y are symmetric. That means x should be in the middle. So I'm already thinking the sequence should be y x z or z x y, one of the two. So x should be in the middle. This is possible. This is not possible. This is not possible. This is not possible. This is our answer. None. Obviously, in an exam context, I'm trying to be street smart in doing this. But now when we are solving it, we're going to try to see if this can work. Right? The two approaches to it, we've guessed it, and then plug it in. Y, x and z are in arithmetic progression. So say, hey, I could take x, y and z to be 1, 2, 3, 2, 3, 4, 3, 4, 5 and then validate this. That's a possibility. Or take x as y as x minus d, x, z as x plus d, and then simplify this and see where it takes you. Those are the approaches that we can take because we know that this looks like the answer. With other three, x is not even in the middle. I can eliminate that. Right? Otherwise, what do? We know that root y, 1 by root y plus root z, 1 by root x plus root z, 1 by root x plus root y are in arithmetic progression. How do we know that? Because that middle term is the arithmetic mean of these two. This number is this plus this by 2. Or if I think about it differently, root x plus root z, root y plus root z, root x plus root y are in harmonic progression. Reciprocals of these are in AP, or these three are in HP. The definition of harmonic progression. If you have A, B, C in A something B in harmonic progression, should be the harmonic mean, which is 2AB by A plus B. Or we can say root y plus root z equals 2 times root x plus root z into root x plus root y divided by A plus B, this plus that. 2 root x plus root y plus root z. We cross multiply and then just see where it takes us. Root y plus root z whole square, which will be y plus z plus 2 root yz plus 2 root xy plus 2 root zy equals 2 times root x into root x is x plus root xy plus root zx plus root zy. Nice, this is equal to that, which is nice. 2 root yz, 2 root xy, 2 root zy, 2 root xy, 2 root zx, 2 root zy. Nice and symmetric on both sides. So what am I going to do? I'm going to just knock this off. Or y plus z equals 2x. Y plus z by 2 is equal to x. X is the arithmetic mean of y and z, or y, x and z are in arithmetic progression. Choice 1, choice A. I struggled long and hard to establish this. It took me a while to punt the answer, verify the answer, substitute with x plus 2x minus d, then do brute force in several layers, then come to this solution. So it's not one solution which is like this. This is not how I thought about it. I arrived at it after like long struggle. A lab experiment measures the number of organisms at 8 AM every day, starting with 2 organisms on the first day. The number of organisms on any day is equal to 3 more than twice the number on the previous day. So D2 7. The number of organisms in D3 will be 7 into 2, 14 plus 3, 17. D4 is 37. D5 is 77. D6 is 157 and so on. The number of organisms on the nth day exceeds 1 million in the lowest possible value of n. Pain in the neck question, and properly pain in the neck question. Because this is not an AP or a GP, this is an exponential sequence. So AN is 2 times AN minus 1 plus 3. And so a lot of these questions, it really helps to say, what is this difference? It's a first order difference. This is 5, 10, 20, 40, 80 and so on. Which is nice. The difference keeps doubling. This number plus 5, this number plus 10, this number plus 20, this number plus 40, this number plus 80 and so on. Now I'm going to say, hey, I take out a 5. 5 into 1, 2, 4, 8, 16 and so on. This is a geometric progression. Or I can say D2 is D1 plus 5, D3 is D1 plus 5 plus 10, D4 is D1 plus 5 plus 10 plus 20, or I can say Dn equals 2, which is D1 plus 5 times 1 plus 2 plus 4 till it's, how many terms am I adding? I'm just thinking about it. D2, I'll add only one term. D3, I'll add till 2. D4, I'll add till this point. Dn, I'll add till 2 power n minus 1. Nice, lovely. Now 1 plus 2 plus 3 till 2 power n minus 1 is 2 power n minus 1. 1 plus 2 is 3, 4 minus 1. 1 plus 2 plus 4 is 8, 7 minus 1. 1 plus 2 plus 4 plus 8 is 15, 16 minus 1. Or Dn is 2 plus 5 times 2 power n minus 1. Dn is 5 times 2 power n minus 5 plus 2. 5 times 2 power n minus 3. So D1 is 5 into 2 minus 3, 10 minus 3, which is 7. D2 is 5 into 4 minus 3, 17. I think I've got the formula right, but I've got the ends mixed up. Right, so D4 is 2 plus 5 into 7, 5 into 35, 35 plus 2 is correct. There seems to be some mistake I've done somewhere. 2 plus 35 is 37, that is nice. 2 plus 2 cube minus 1, correct. So this is the n minus 1 terms in this sequence, but there's a D1 remaining. So what I'm doing here is Dn plus 1. And so the expression is right, but I've made one step mistake. And so Dn plus 1 is 5 times 2 power n minus 3. So if you put n equal to 0, which is D1, this is 2, D2 is 5 into 2 minus 3, correct. D3 is 5 into 4 minus 3, 17. Yep, this works. Or I can simplify this and say nth term of this sequence is 5 into 2 power n minus 1 minus 3. This is not enough, it's not sufficient, because we've been said the number of organisms on the nth day exceeds 1 million. So nth day, the number of organisms will be 5 into 2 power n minus 1 minus 3. So we have to find the smallest n such that 5 into 2 power n minus 1 minus 3 is greater than or equal to 1 million. Right? I'm going to ignore this 3. The 3 doesn't matter, right? So 1 followed by 5 zeros. So 2 power n minus 1 should be greater than or equal to 2, 0, 1, 2, 3, 4, 200,000. Right? So 2 power n minus 1 should be greater than or equal to 200,000. An unholy large number. I know that 2 power 10 is equal to 1024. 2 power 20 equal to square of this 1048576. 1048576, more than this. 2 power n minus 1 should be greater than this. So 2 power 19 will be greater than this because this is by 2, 500,000 something. 2 power 18 will also be greater than this. 2 power 17 will not be greater than this. So this is 2 power 20 greater than or equal to 200,000. 2 power 19 is greater than or equal to this. 2 power 18 is greater than or equal to this. 2 power 17 doesn't work. So n minus 1 should be at least 18 or n should be greater than or equal to 19. Minimum value of n is 19. Again, a wonderful question, wonderfully tough question, pain in the neck question that we should be like, no, very interesting, very fun, but I'm not doing this. And good practice to kind of muck around with questions of this level of difficulty. But honestly speaking, I don't know why they are toying with this levels of difficulty for an exam that takes students for MBA. And so again, that's my opinion. So obviously they think this is of importance, and so we'll stick with that. Lovely.